Okay, so today we are largely doing QA because you guys are getting slowly towards the stage where you want to get stuff done. Reason enough. One of the issues, yesterday we had a reference group meeting, and one of the issues raised there was, please.
Can you zoom in a bit?
All right. Oh, yeah, we're there already. So one of the issues was made that we need to give more QA. So the decision is during the assignment periods, we have a considerable amount of QA on the Thursday sessions. That's more sensible, unless there is a need for switching it around for some timing reasons. But we want to keep it this way, so hopefully that will work for everyone. I think that is what I'm doing, yeah. Does anyone know the shiny fancy shortcut for Golang in this case? Ah, right, that's not helping.
Control plus.
Control plus, was it? Good. We do 20. Let's go for that. Good. My plus thing doesn't work. Yeah, my keyboard has a few broken things. Anyway. Sorry?
In the settings. You
What?
can enable scroll zooming in the settings somewhere. And
Right.
You can zoom while control as well.
That sounds good. So one of the issues is most of you guys worked yesterday on the one of the handlers that you're supposed to work on, right? So in the thing, did anyone experience something surprising? I know one person did. It wasn't me. Right, that person did, right? Anyone else? No? Okay. No 503s? Good. So okay. So that's good. So yesterday was a good example of why we should do mocking. So the lbif correct me service went down, so it didn't really produce anything, but produced a 503, implying something's wrong on the server side, right? So the instinctive reaction is, oh shit. Probably we shouldn't have given out that as an assignment, as in the server is not available. But it came back up yesterday evening, so that's good. But it lends reason for another issue, because especially if you do the occurrence search, and most of you came across that one, I suspect, as part of filtering your species for given countries, there can be considerable load on this one. It's not like super responsive, particularly that page, and I suspect they do a kind of a raw search on the database. However, it's implemented on the back end. We wouldn't know, it's REST, right? We only know the front end, basically the interface. We have no clue how they implemented it, right? If they use MongoDB, if they use relational databases, if they are taken from flat files, who knows? So the idea is, okay, in order to mitigate those issues, in order to perhaps also improve your testing on your own, why not create your own mock handlers, right? Or your own mocks, basically, for any sort of service. And what is the idea with the mock again? Can anyone remind me of what a mock does? My memory is a bit broken, so I need some help. Please, there you go.
It pretends to be the server for you.
Yeah.
For testing purposes.
So what do you need to do then if you wanted to implement one?
You need to do a query against the real server.
Yeah.
And basically make your own server that handles that query, all the queries that you need.
Yeah. Good. Yeah. So that's for the need thing is important, right? For all what you need. What's the simplest form of a mock server you could think of if you were to construct one? What was the simplest form of a mock server?
A function.
Elaborate a bit more. What do you mean function?
You can just make the handler function, and you can use HTTP testing package from Go.
Yeah.
And just run a separate recorder against that.
Yeah, that's right. This is for testing, right? Yeah. That's good. That's a good extension. So, but let's stay on the pure mocking side. So testing is another one. That's a very nice one. We need to have a session on testing anyway. I probably need to have that happen the next few weeks. But let's look at the pure mocking without the testing component for now.
Copy the JSON from the API to the string.
Exactly. So bluntly copy that stuff, right? You get your query, copy the content, keep it somewhere, file, for example, and then you write your own mini service that basically reads that file and just produces back to the client. That's it, right? So that's the simplest form. So then you said, depending on what you need, right? What are the things that you need? Well, how many methods does your service need to support, right? Do you need a post method on that service? Probably not, right? HTTP REST method? Do you need to deal with a diverse set of parameters? For example, different variants of country code? Perhaps, perhaps not, right? Because we know that the structure that it returns is uniform. So it may not matter just for the parsing, for example, if that's your problem, to retrieve the content. But of course, it would matter if you want to deal with different country codes and stuff like this. Then you need to have different versions of your service to deal with this. But just to have a template for the simplest possible form of mocking, and I think that's very accessible, because the idea is not to write too many additional services. But if you're just keen in just reproducing it, here's some mini inspiration, I guess, in this direction. So you basically just write a conventional kind of main for your particular service. So this is the service. We're assuming we're listening on port 8080, and we are on the right now on the pattern slash. So basically, at the root of the REST service, we simply attach the mock handler right now. Of course, you want to replicate the URL you're interrogating, right? It would be something like occurrences, search, and so on, right? So, but that's where the handler should basically sit, and then you have it listen, of course. And
Is the text still too small?
it's still too small.
That was the question. Is it too small still?
Try my best by scrolling here.
Right, no one complains, so it's fine.
Is that good?
Oh.
That's good. Okay. It's touch. Don't touch. So right. So and that's relatively straightforward. So let's just see the structure here. So we have the usual CMD nesting for the main function, and the rest is here manual and internal. And the only thing that's literally there is basically a mock handler. What does that thing do? Well, we know how handlers look like. It literally reacts only to the method get, HTTP get. It ignores everything else. In fact, it doesn't ignore it. It sends an error, right? It sends the error, handler not implemented, and provides a status code 500 or 502 is that? What is status not implemented? What's the HTTP code for that? Doesn't matter. It's in the standard anyway. So I think it's 502. And so when you get a valid request on GET, you just produce the header information, such as the content type you specify, and then you bluntly return whatever you got from the file you previously downloaded. So to contextualize, I basically went to the page, ran my choice. Oh, that doesn't read well, does it? And basically just copy and pasted that stuff, or rather saved that page into a JSON file. That's literally the default query from occurrences. So that's now here available in resources. And then using this function here very briefly, basically read this file using IOUtil and returning basically the content of that file for further processing. It returns it as a byte array in this particular case if you use read file. And I'll parse it here then, right? In the get handler, I basically just say, oh, take this file now as a response, right? And stringify the output and simply return this to the request. And that's it. So that's the whole handler. So it's quite straightforward, right? Does it make sense to everyone? No is fine. No is even better than yes. No response means they're not here yet. It's okay?
Extra points for no.
Yes, that's right. Extra points for that would be people would get a lot of points here. That's a bit scary one, right? So you get the idea. You have one handler. This handler does only do one thing: literally read or parse this particular file, and then presents it back to the client, right? And breaking out of it. That's it. If you need more, please.
Do you actually need break there?
Probably not. No, that's right. I was preparing for more statements. That's right. What here, of course, is not here in the handler, right? This is really raw, if you like, right? We don't consider parameters. We don't consider the URL, the correctness of the URL. We're basically just reacting to anything we get. We're not extracting parameters. We don't look at the body of the GET request and whatever else, right? So from a testing point of view, that's not complete, but from just mocking and getting something so you can parse it on your side, that's sufficient. But it's a baseline you can start working from. This snippet is provided as part of the repository. You'll find it's called RESTMock. So you can just play with this and see if you can spin it up and modify it to a liking, or just read it again to understand it. What's happening there. it's relatively straightforward. So, but this is kind of a nice default pattern. So if you, especially dealing with heavier services, just download the JSON, or if you want to work offline, even better, right? You want to work at home or something, then it's the easiest way of dealing with this. For us, the I guess lesson learned would be if we have closed APIs, we just need to scrape everything first.
Yeah.
Just provide you raw JSONs.
Make sure to have a backup.
That's a tough one. Well, it went well, lucky us. But I would recommend you to pull all pages that you're working on, or against rather, so you have them backup anyway in case this kind of thing occurs. So you can quickly substitute them with this mock or any other mock of your liking. Comment? No.
No.
Good. Okay. So I'll leave that under, or I have left that under. REST mock, yeah, down here, right? So that's exactly the kind of stuff I just showed you, so you can just download and play with it. Okay, on another note, we there was also the since the first assignment did had various iterations, I think roughly 3 or something, until it was seemingly hardened or somewhat hardened. You guys have probably wasted quite a bit of time of getting your hands around the specific APIs, only to see that we abandoned them. So sorry for that one in the first place. Yes. So we want to repeat this exercise again. So the idea was, hey, for the second assignment, which we actually have ready, we'll hand the description out early and give you a roughly until next week, that would be next Wednesday, to kind of review it and see if that makes sense from a sanity point of view. So don't work on it, just look at it, and then we discuss it in class and see if it makes sense or doesn't make sense for you, and how we could possibly attack that one. I just briefly introduced the assignment. It's raw in the sense that it's not completed with respect to certain formal details, but the specification is complete. And the idea is just to prepare you for this one. We were not working against the animal API or species API there, but rather against our GitLab deployment. So the idea is you're working against our service. Has 2 advantages. Number 1, if they come down, we can deal with this. Number 2, we don't have rate limits, so they will be available, hopefully. So that's the idea there. And what we expect or ask you to do is to develop a service that inquires, works against this API, GitLab, which is documented here, so the link is all there. And in fact, at great detail, allows you to inspect projects, issue trackers, and so on. So a lot of opportunities for just getting hands dirty with REST at great level of detail, while concentrating only on one service. So that's the key idea. And what we want you to do is basically have a service that provides different endpoints. They are named here. So one is called commits, the other one is called languages, issues, and status. The idea is that your depending on endpoint, your service will identify the users with the largest number of commits, the most frequently programming languages used, the issues, or the users that the users that posted the most issues, or respectively the labels that are associated with most issues, and a status kind of endpoint. So nothing fundamentally different from what you know already. So just with the variation that you actually work against GitLab API, which is hopefully fairly stable. Also, GitLab works differently with respect to 2 situations. So if you work unauthenticated, you only get the public information. And if you want to get internal or private information, you need to be authenticated. So it's the authentication component as well as a parameter there. That's the idea. Yes. So the syntax there is expressed in some sort of crude regular expressions, if you like. So you can specify a limit of commits that you want to have. And of course, whether you're authenticated or not needs to be indicated as well. Similarly for languages, so you can have an arbitrary number of numbers, basically, of the limit. But we realistically wouldn't expect much more than 10 or 15 or something like this. So you wouldn't want to test it against 999 or values of that number. I probably would not be comfortable with the implications. Unless, you talk to Lars Erik what our system can actually deal with. So the more interesting thing, and that's the novelty, so this one is not terribly novel other than we have a different API, slightly different output structures, is the request to develop webhooks. And we haven't talked about those guys yet, but we will, because they're also quite important, but they're fundamentally not different from anything else you do in REST. The idea is basically there, upon certain events, you can register a webhook which receives a notification, right? So, for example, if you can do that quite sensibly. For example, if a commit is lodged in GitLab, you can, in principle, ask for email notifications or the like, or a notification to Discord or Slack or whatever else. That would be classical use of webhooks, where basically an event trigger happens. We haven't talked about those yet, so I'm not going into a great amount of detail at this stage. I'm just telling you that this will we will talk about it, of course, as part of the assignment. But the rest should be reasonably well documented, even the webhooks themselves. But again, I'll come back to that once we actually talk about it, so it makes more sense. Otherwise, I will just overwhelm you. In any case, the different endpoints, the specification is all provided here below. So for the endpoints commit, for the endpoint languages, issues, and so on, you find how the request should look like, what it should provide, what the default return is, what the response data structure should look like. For languages, the same. What is the request, the potential body that you provide, the parameters, what they're defaulting to, and the potential responses you would expect. And for issues, similarly, the issues is different in that we want to have the issue information for a given project, not for all projects. So here you have some payload which contains the project name you want to inquire, right? If you recall the structure of GitLab. So if we have a given project, in this case, we just want to know about the issues in that particular project as opposed to all projects, which is, of course, another option as well. Right, so that's the idea for this one. And how does the response look like? Well, the response depends on what kind of information you want to get. If you want to get issues related to a given user, you specify this as one of your parameters, and then the return structure would look like this. And if you want to have the labels, the respective counts of their labels, then you would return a structure like this. So structurally similar, but users there. Status we always do. Provide some up. I'll come back to that when we